Hello, everyone, and welcome to Lesson 7.4, Part 2 on addition and subtraction. So, picking up from where we are, we just covered multiplication, division. Now we're going to talk about how to add fractions. Now, you see, multiplying, dividing is relatively easy because it's really just factoring, canceling, and multiplying across. You see, when you have 1/2 times 1/3, you just multiply the numerators. 1 times 1 is 1. And the denominators, 2 times 3 is 6. And it ends there. That's multiplication. And if it was division, well, then you would just flip the 3 as 3 over 1 and then multiply, right? But addition and subtraction, doesn't really matter if it's plus or minus. To do addition and subtraction of a half plus a third, you need what's called a common denominator, right? These aren't the same parts, right? You can't say, oh, this is a half and this is a third, right? You can't add these and say this is 2/5. You know, that doesn't make any sense. Like what? I don't even know what 2/5. I don't even want to draw that. So you have to have a common denominator. And one way you do that is just multiplying by the other denominator. You see, if this was 1 over 2, that's 1 over 3, then on the 1/2, the other denominator is 3, so you multiply this fraction by 3 over 3. And on the 1/3, the other denominator is 2, so you do 2 over 2. Then through this multiplication, you get 3 times 1 over 3 times 2 is 6. And 1/3 times 2 over 2, that's 2 over 6. And now that they have the 6 in common, right, that's like the part, right? That's like the size of the fraction you're adding. Then you can add those two parts together to get 5/6, right? And that's the basic premise of adding fractions, right? Now, what if you had, and I'm spending time on this for a reason, because we're getting to rational expressions. And how you really think about these is going to help be efficient in your algebraic solving. So suppose I wanted to do 1/9 plus 1/6, right? And if I wanted to repeat the process I just did with the half and the third, an effective way, or I'll just say a way to do it, to get a common denominator, is to just multiply by the other one, right? To say, oh, take 1/9, multiply it by 6 over 6, and 1/6, multiply it by 9 over 9. This would get you 6 over 54 plus 9 over 54, because 6 times 9 is 54. Adding those together, you'd get 15 over 54, right? And then you'd have to ask, does that divide any, actually? Isn't 54 divisible by 3, you might ask? And you would say, yeah, it's 18. And isn't 15 divisible by 3? You say, yeah, it's 5, right? And so then you'd get this 5/18 from there. And this is fine. Doing this with fractions works, right? Because you found a common denominator, and it was relatively easy because you just had to find, you just multiply by the other one. But even though that was maybe relatively easy, was it the most efficient route, right? Because did you automatically assume or know that 15 and 54 shared a common factor of 3? Or is that something you would have had to test to ensure that you've really factored everything, that you've found the common factors and fully simplified the fraction, right? I say, well, there is another way, and you know it, and that is, well, you could get a common denominator of 54, but actually there's a smaller one that would basically work too, that would service us just as well. And some of you are yelling at the screen, 18, 18. And I say, yeah, 18, right? Because if you took 6 and multiplied it by 3 over 3, and you took 9 and divided by 2 over 2, then you get 2 over 18 plus 3 over 18 is 5 over 18. And then when we do it this way, we don't even have to simplify the end fraction, right? We just already have it. And there's no more work to do. But then the question is, how'd you know to do 18, right? How'd you know why that, right? And the thing is due to practice, due to your experience in, elementary and middle school, you're just your brain, it knows its multiplication table, so you just kind of know that it's 18, but why, right? Why? How do you figure that out? And how might you figure that out if I gave you like 5 over 34 plus 6 over, I don't know. I'm thinking here. Hold on a second. 51, right? Or something like this. So how would you even know? Like, would you multiply this by 51 over 51? Would that even be what you want to do, right? That's what we're going to talk about. So I want to talk one more example about fractions before getting to the algebra, and that is a comparison. Finding a common denominator versus finding what's called a least common denominator. And trust me, you're going to want to find the least common denominator. So here's an example that will illustrate one more time what we just were talking about. 5/6 minus 11/15 plus 3/4, right? If you were to do this, the way we were just doing, to find a common denominator, 5/6, you can guarantee this by multiplying by 15 over 15 and 4 over 4. And then when you move to the 11/15, you can guarantee a common denominator by multiplying the 15ths by 6 over 6 and 4 over 4. And with the 3/4, again, you can guarantee the exact same common denominator by multiplying by 15 over 15 and 6 over 6. But without a calculator, tell me what 6 times 15 times 4 is, and what 5 times 15 times 4 is, and what 11 times 6 times 4 is, and what 3 times 15 times 6 is, and right? Here's a little sweat, right? A little, here, let me see, a little, right? No, right? I don't want to do that. That is not fun. So this would work. It would. It's a good way of finding a common denominator. It's always going to work, but is it the best way, right? You say, no, it's not. It's not the best way. But it's also, it may be clear to you, depending on how strong your multiplication tables are, but do you just look at 6, 4, and 15 and immediately know what the LCM is? In other words, what's the least common denominator or least common multiple? The smallest number divisible by 6, 15, and 4. Some of you are going to say, yeah, Mr. Spake, I know. But most of us, including me, might say, I don't know. Like, I don't know instantly what the smallest number is. Here is how you can find that. So here's method 2, the better method. So I'm going to copy this down. We got 5/6 minus, what is it, 11/15 plus 3/4. Okay, 11/15 plus 3/4. Okay, so you want to find the smallest common denominator, right? The way you do that is look at the factors. So 5/6, right? You don't care about the top. The top doesn't matter. It's the bottom. 6, factor that. What's its prime factorization? It's 2 times 3, right? 15, well, that's 5 times 3. And 4, well, that's 2 times 2. So what I'm going to look at is, what I want is the least common denominator. I abbreviate that LCD, right? So how do you construct this? Well, the least common denominator, it's the smallest number divisible by all denominators. That means it shares all the unique divisors of each denominator, right? When I say unique, I mean the divisors that are specific to a particular denominator. I say, Mr. Spake, that's not helping. And I say, look, let me show you. Look at the first fraction. You got 2 factors in the bottom, 2 and 3. So your LCD needs to be a number divisible by 2 and 3. You can guarantee this by including 2 and 3 as its factors. Okay? Move to the next denominator. This number needs to be divisible by 5 and 3. That's the LCD needs to be divisible by 5 and 3. So I'll multiply this again by 5. But here's the thing. I say, look at this. 2 times 3 times 5. First of all, that's 2 times 3, that's 6. 6 times 5 is 30. Is 30 divisible by 3? Yes, it is. So the thing is this 3 that's in the denominator, you already have it in your LCD that you're constructing, right? It's already present there. So it's already common or shared between this fraction and this fraction. So there's no need to put another 3 here because this LCD is both divisible by this 3 and that 3, right? Now move to the last one. You have 2 and 2. Well, using that same logic, you have this 2 here, but you don't have a second one. So the LCD is going to need another 2. Because this denominator is 4. And if I didn't have this 2, the LCD would be 30. But is 30 divisible by 4? Say, no, 30 is not. That's like, what, 7.5, right? And I say, I don't want that, right? So I have to have the other 2 here, yeah? And so now I've basically gotten all of the absolute essential factors that I need, right? It needs to be divisible by 4, 15, and 6. And so I just looked at the unique factors, right? This 3 was not unique because of that 3. They're already in common. But this 2, you had this 2 and this 2, which were already, common, but this one wasn't, so you needed another. So put this all together. 2 times 3 is 6, 5 times 2 is 10, 6 times 10 is 60. That's your least common denominator, right? So I say this equals, you know that this will be 60, this will be 60, and this will be 60, right? I'm going to switch to blue here. Look at this fraction and think, what do you need to multiply that denominator by to match this? Well, you already have a 2 and a 3. What you need is a 5 and a 2. So you would multiply by 5 and 2 on top and bottom. Thing is, you know what 2 times 5 is? It's 10. So this 10 multiplies this 5, getting you 50. Yeah? You are doing that to the bottom too, 2 times 5 times 3 times 2, but that's just 60, and we already knew that. And so this is going to happen for the rest of these as well. We already know what the bottom is. It's going to be 60. So what's the top, right? So move to the next fraction, 5 and 3. Well, I'm going to come back over here. I already have a 5. I already have a 3, but there's not a 2 and a 2 here. 2 times 2 is 4, so I need to multiply the top by 4. 11 times 4 is 44, yeah? And then that 2 times 2 times the 5 times 3 is, again, the 60. One more time with the 3 over 2 times 2. With the 2 and 2, you already have those 2's, but you need the 3 and the 5, which makes it 15. So you're going to multiply top and bottom by 15. 3 times 15 is 45. And now you can add all of this nicely together. By the way, this was a plus right here. 50 minus 44 is 6, plus 45 is 51 over 60. Oops, whoa, which is my answer. By the way, with that 51 over 60, you should still see if that can be simplified. And actually it can. This was actually a little tricky. This is because 51 is a multiple of 17. That's 3 times 17 over 3 times 20. So the 3's cancel. This fraction simplifies completely to 17 over 20. Okay? 51 over 60 is a correct answer, but 17 over 20 is, I guess, the preferred answer because it's fully simplified. Yeah? Now, I've been talking a while about just basic fractions, right? But there's value in this because if you really understand, for one, why we don't do this way and why this way works and why it's effective and efficient, then that's going to help you when you do these examples. Okay? So I'm going to walk through these, and each of these is really good at demonstrating what you need the LCD for. So number one is a good example because these are the really common ones you're going to see. X minus 1 is the first denominator. X plus 3 is the second denominator. These don't share anything. By the way, you might ask, do they share an x, though? And the thing is it's about the factor itself. Like, as a group, x minus 1 is different from x plus 3. They're different quantities, right? They're different expressions. So, what's the least common denominator? Well, you need a factor of x minus 1 because of this guy. And in the other one, you need a factor of x plus 3, which is that one. And so that's the least common denominator. So, and I didn't do this in class, but I'm going to do it here in this video and show you how you might write this. So you've got 5 over x minus 1. You're going to multiply this. You want the LCD to be this, so it's missing the x plus 3. So you got to do x plus 3 here and x plus 3 here. Plus, and then you got the 8 over the x plus 3 here. You have the x plus 3, but you need the x minus 1. Now, I want you to notice what I've written here, right? The denominator was expected. We got the least common denominator here and here. What I would say is, I don't need to see you write this step right here. This is part of just multiplying it, making a match. On the next step, you know that the common denominator is x minus 1 and x plus 3. So what's the numerator? Well, you multiply this numerator, 5 times x plus 3, and you multiply this, so it's plus, because of that plus sign, did 8 times x minus 1. Now, if you distribute this, that's 5x plus 15, 8x plus minus 8. So 5x plus 8x, because again, plus sign here, is 13x, and 15 minus 8 is 7. And this is over x minus 1, x plus 3. And done. That's how we add those two fractions. Yeah? And that's basically it. But this one doesn't exactly show why an LCD is really necessary, because neither denominator actually has anything in common. So it's really just multiplying each other, to the other one. Let's go to number 2, though. This one's interesting. Okay, number 2. So I'm going to go ahead and factor the denominators. If you want to pause and try this for yourself, you can. But I don't care about spending time factoring. I care about showing you how this process works. So the denominator on this first one is a perfect square trinomial, factoring as 3x plus 5 quantity squared. This happens twice. The other one, you got 3x squared minus x minus 10. That's going to be 3x, and then let's see here. This is going to be x. I'm probably going to want, is it plus 2? No, minus 2? Like this? Plus 5? Yeah, I think that works. Yep. So that's the factorization of that denominator. Okay? So now you say, okay, well, what's the least common denominator, right? What factors are shared? Well, if you look at the first one, you need a factor of 3x plus 5, but there's 2 of them because it's squared. So the LCD needs 2 3x plus 5s. And when I say 2 of them, I don't mean 2 times it. I mean 3x plus 5 times another 3x plus 5. That's represented by that exponent 2. Now you move, so I got this one. Now I move to the other denominator. Whatever my LCD is, it needs to be divisible by 3x plus 5 and x minus 2. Well, I don't have an x minus 2 factor at all, so I'm going to put that there. But this 3x plus 5, well, it's kind of covered by that 3x plus 5 squared. That square implies that there's 2 of those, and this factor only occurs 1 time, so I don't need another, right? I don't need any more. It's good. And it's the same reason up here why, you had a single 2, that's like this 3x plus 5, but then 2 times 2 is like 2 squared. You needed the 2 2's because of that denominator had 2 2's, so you needed this 2 and that 2, right? Same reason why you need 3x plus 5 squared, because this one has, 2 of those same factors. Okay, now, how would I go from here? Well, I would say I want to match the LCD. So if I look at this denominator, what's missing, I've got the 3x plus 5 squared, but I need the x minus 2. So I'm going to multiply by x minus 2 on top and bottom like this. Okay. On the other one, I'm going to switch to yellow here. Here, you have 3x plus 5, x minus 2. Well, 3x plus 5 times 3x plus 5, x minus 2, you have that within the LCD there, but what you're missing is the extra 3x plus 5. So you need to write 3x plus 5 top and bottom here. Okay? This makes the denominators match. So on the next line, the common denominator is 3x plus 5 squared times x minus 2. In the numerator, you have 2 distributing to x minus 2 plus 4 distributing to 3x plus 5. We're going to distribute this. That's 2x minus 4. That's 12 plus 12x plus 20. Put all of that together. 2x plus 12x is 14x. Negative 4 plus 20 is 16. And this is over 3x plus 5 squared, x minus 2, and done. And that's how you add those together, yeah? Because, look, if you were doing the first method, this method, right? This method, in number 1 here, we just multiplied this guy by this guy, right? You know what I mean. Multiplying one by the other. Did you want to do that here? Did you want to take this fraction and multiply by 3x squared minus x minus 10 on top and bottom? And then multiply the other one by 9x squared plus 30x plus 25 on top and bottom? Oh my gosh, that's so much. That's terrible, right? We did not want to do that. That just would not even be fun. Oh my gosh, it would not be fun at all. So, there it is. Okay, that's 1 and 2. Let's go to the student practice. So, I do recommend trying this for yourself. If you want to pause the video, continue in the notes on your own, but I'll go ahead and cover them now. I would watch these extra 2 examples if you're watching this from home. Adding and subtracting fractions is one of the biggest challenges I find students face in this unit. So the more examples, the more acclimated you get to seeing this. Okay, so here's number 1. Let me show you what a common student mistake, well, it's not really a mistake, but it's just, I guess, not the best direction, yeah? They would say, oh, okay, let me take x squared plus 16 over 5x minus 2, and let me just multiply that by the denominator x minus 2. And then let me take the x minus 2, and I'll multiply that by the other denominator, 5x minus 10 on top and bottom. Would this work? Yes, but I'm not going to like it. It's not going to be very fun because I have some quadratic distributions here. I don't want to do that. I don't want to do these binomial distributions and get a bunch of quadratics, yeah? What I'm going to actually do is start by factoring. X squared plus 16 over, factor out the 5, I get x minus 2 there. Now look, what's the LCD? Well, you need a factor of 5, and on this denominator you need a factor of x minus 2. So you put that in the LCD, 5 and x minus 2. Now go to the other denominator. You have a factor of x minus 2. Oh, well, Great news. 5 times x minus 2 already has a factor of x minus 2. You don't need another, right? You don't need actually anything else. And so if you wanted to make them match, all you'd have to do, this is x minus 2. You just need the 5. So you multiply this one by 5 over 5. And notice, as I switch to blue yet one more time, this and this are now the same. You actually don't even need to change the first fraction. X squared plus 16, right? This is over 5 times x minus 2. Drop the minus, and then it's 4 times 5, which I'm just going to write here. 4 times 5 is 20, like so. Yeah? And of course, 16 minus 20 is negative 4. Now, seeing that, x squared minus 4, when we do fractions, kind of like when we did this one up here, where is he? This guy, the 51 over 60, which was 17 over 20, right? You want to simplify it if possible. So the question is, can you simplify this expression anymore? And you say, well, x squared minus 4 is a difference of squares, x plus 2, x minus 2, over 5 times x minus 2. Now the x minus 2's are in common and cancel, leaving you with x plus 2 over 5. Our nice answer like that. Okay? Now, I find when I teach this, a good number of students ask, why didn't this one change again? Right? Like, I see the 5, I guess, but why didn't this one change? And I'd say, look, it's just like adding 2/3 plus 1/9, right? What's the least common denominator between 3 and 9? Well, it's 9. I mean, you could make the denominator 27, but if you were to multiply the 2/3 by 3 over 3, you'd get 6/9, which can be added with 1/9, right? So this is an example where the least common denominator is one of the denominators, right? The first fraction already had the LCD. The other fraction just had one of the factors. He just needed the other one, right? He just needed the 5 over 5, and now it matches. So that's why that kind of works out that way. Okay, now this last one, it's a bit of a challenge problem, okay? It's to really just push you in your algebraic understanding, but it's really good practice. So I'm going to go ahead and factor this. The first and last fraction actually don't factor, but the middle fraction is a perfect square trinomial, making it x plus 1 squared, okay? And that means the x plus 1 factor is happening twice in that denominator. So it's a double root, right, or a double factor. So my LCD, you need an x plus 1 and an x minus 1 from those two pieces. But this term, you need an x plus 1, but it specifies you need 2 of them. So your LCD needs 2 of them, has to, yeah? It doesn't need 3 of them, notice. Some students say, oh, it has 1, 2, 3. I said, no. This one is already shared within that one. You just need a power of 2, okay? Now, if I put this together, the 1 over x plus 1, right? This guy. You have, I'm actually going to rewrite the LCD for you to help you out a little bit here. X plus 1, another x plus 1, and then an x minus 1. That's your LCD. You have an x plus 1. What you're missing is an x plus 1 and an x minus 1. So in the numerator, you need x plus 1, x minus 1 times the 1. Denominator, same thing. Okay? I'm going to switch to blue. This is x plus 1 squared, which is covered by these two x plus 1s. Yeah? But what it doesn't have is the x minus 1. So you need an x minus 1, top and bottom, to make that one work. Let's switch to green. On the last one, you have x minus 1, which is covered here, but what you're missing is the other two x plus 1s. So you need an x plus 1 squared on top and bottom, like so. And so that is what kind of makes this all work. Now, the denominator, I'm just going to put this all over. It's just x plus 1 squared times x minus 1, like so. But the numerator is 1 times x plus 1. So I don't really need the 1. I just need the x plus 1, x minus 1, plus, that's the plus, 1 times x minus 1, that's just x minus 1, minus 1 times x plus 1 squared, which is just x plus 1 squared. Now, if you expand this, right, and you do distribution, that means you multiply this out, and then, this one is x plus 1 times himself, and you expand that out, right? Go ahead and do that. You're going to get x squared minus 1 plus x minus 1 minus, in parentheses, x squared plus 2x plus 1. And the thing is that minus sign's actually going to distribute. So I'm going to actually erase those and put minuses now. Like that. Okay? All over x plus 1 quantity squared, x minus 1. Combining like terms, x squared and negative x squared cancel. And then positive x minus 2x, well, that's negative x. And minus 1 minus 1 minus 1 is minus 3. And just for the sake of it, the top, you see those two negatives there. You could factor out a negative and get x plus 3 here. Denominator, x plus 1 quantity squared, x minus 1, and done. So that is that problem there. That's a tricky one, yeah? Don't get too stressed. You're going to see something that difficult on the test, but it's really good practice to get you acclimated with what's the LCD, how do I add these things together, and it's really good practice because of the distribution that's up here in the top, yeah? Because there's a lot going on there. You have to multiply all of this out and combine like terms within the numerator. So it's all about beefing up your algebra, making you nice and strong, ready for anything pre-cal or calculus might throw at you. And there it is. So that's the lesson on addition, subtraction. I'm going to end the video for this part 2 here. One more to go, though, is part 3 on simplifying complex fractions. So make sure you check that one out, too, because it's still pretty important. So thanks for watching. See you in the next one.